Hello, and in this video we're going to discuss the one-way analysis of covariance, or ANCOVA, and specifically how to do it in R. I've already done a video on this analysis in SPSS where I go into a lot of detail about the computation and some issues with ANCOVA, but in this video we're not going to focus on that. We're going to focus on how to actually do it in R, because I'm hoping that a lot of the understanding will transfer over, because R has some specific things that you need to watch out for. So I want to focus specifically on the R stuff rather than the theory, because I've already done another video on that. So briefly, ANCOVA is a technique where we can look at the differences between two groups on a continuous dependent variables. So just like an ANOVA, but we can do that while removing some of the error variance created by the variable, the covariate. Anyway, let's dive into our example in R. I've got R open down here, and we see we've got the same data as we did in the previous video. We've got a grouping where someone either saw cross-examination just by the prosecution, or they saw cross by the prosecution, and then the defence had the opportunity to come and clean up, and then we asked them for a rating of the credibility of this witness, but we also said how pro-defence or anti-law you are might explain some of the variance that might eat up some of the error and give us more powerful analysis. So that's what we do for ANCOVA. But how do we actually do the analysis? Well, we do it through the A or V function, just like we do with any other ANCOVA. But what do we actually need to do? It has all the regular assumptions of ANOVA, but the few assumptions we need to check first: the homogeneity of regression assumption, that the covariate and the dependent variable have the same relationship in all groups, and that there are no differences between the groups on the covariate. Let's take the first one first. In order to do this analysis, we're gonna need a few extra, one extra package, but I'll get into that as we need it. So to test if there's any differences between our groups on our covariate, I'm just gonna say model diffcov, to tell me that's what I'm testing for, equals AOV, and then scores on our covariate, because we're looking for differences on the covariate. So we're gonna put that in as the dependent variable. So the covariate is predicted from the grouping. Predicted from group, and the data we want you to apply to that is in the data frame ANCOVA .data. Okay, so we've run our model. We now obviously want to see the output. So model diffcov, and we get some output, of course. We see that this p-value is much bigger than 0.05, so we can accept that assumption and assume that we do have equal scores on the covariate between the groups. The next thing we need to test is the homogeneity regression assumption, and that's the relationship that the relationship between the dependent variable and the covariate is statistically the same across all our groups, and we can do that by putting the interaction between the group and the dependent variable or the group and the covariate in as a predictor in predicting the dependent variable. If there's no differences in the relationship, adding in the interaction shouldn't explain any more variability. So we can use a similar A or B statement to what we used before, but in this case I'm going to call it HOR, standing for homogeneity of regression slopes. And in this case we don't want to predict our covariate because we're not looking for differences in the covariate. We want to predict the dependent variable, just like we will be in the final analysis. So, rating. Now, our group's already in as a predictor, but what we want to look at is we're not bothered on whether the groups differ in terms of the rating before it's adjusted for the covariate. What we're interested in is the interaction. Now, we could put the interaction in on its own, but some variability associated with the main effects that's not associated with interaction would get attributed to the interaction if we didn't include all of the variables. So we may lead to rejecting the null hypothesis when we shouldn't be. But actually, in R, if I just put a group times pro defense as a predictor, it will by default add in all this interaction but also the other effects. So if I run that, we again get a model, so I'm going to reuse that summary function to say model homogeneity regression, and we get output for several different effects, but the only one we're interested in here in terms of tightening the homogeneity regression assumption is this one here, the p-value for the interaction, and we see that's far more than 0.05, so non-significant effect. So we can say that the groups do not differ in terms of that relationship between the covariate and the outcome, so therefore we have met homogeneity regression assumption. So we can now go on and actually do our analysis. And to do that, we're going to use the same function, and what we're going to do is include our dependent variable and our covariate, but not the interaction, because that's going to explain other variability that's it's going to think we're just adding pro defense in as another effect, not treating it as our covariate, not adjusting the dependent variable for the covariate. So to accomplish that, what we need to do is say group plus the covariate. Now you'd think, based on the way I explained it in the last video, that if you do this in SPSS it wouldn't matter, but I use a different method of estimating the effects, which is called type 1 or sequential sums of squares, which is dependent on the way you enter your effects. So depending on the way around you enter these, you'll get different results. The way to think about it is that you need to enter your group grouping variable, and then any of your covariates after. That's counter to what I explained before, because I explained in a regression context what this is doing is it's trying to eat up error associated with the covariate first, and then once the covariate is explained all it can explain, it goes on and test the effective group with the new adjusted values. But the way to think about this is we're putting the covariate after, because we want to see how much error it can explain, how much of the error that's left over after the effective group has been computed that it can explain it. So we're gonna run that. And like we've done before, we can just use summary function, and we see that this time where group does have a significant effect on our outcome after the mean has been adjusted for the covariate, and unsurprisingly, because that adjustment has been successful, we know this anyway, but it just kind of verifies that our covariate was able to explain variance in the outcome. The last thing I want to go over is estimation of means. If we look at descriptive statistics, and we can split them by group by saying ANCOVA data group. This isn't homogeneous. This isn't ANCOVA stuff. This is just how you split data apart together in R. We want to see it by group. And what we want to look at specifically is the dependent variable, so ANCOVA data rating. And what we want to know is the mean for that variable split by group, so we're just going to say FUN equals mean. This is just a way to get separate means for our two groups, just so I can demonstrate something. If we run that, we see that the mean in our no redirect group was 8.6 and the mean in the defense redirect group was 15. Well, since in this analysis the effective group has been adjusted for the covariate, these means aren't the same anymore, because the model estimates what the means would have been when the covariate for the error was removed. So to get the means that we're actually using, we need to use a package called effect. If you don't already have it installed, you can run install.packages effect, but if you do, you can just load it up by using the library function. So we're going to say library effect. Effects. And now that that's loaded, we can use the effect function to actually calculate our means. So we're going to say the effect is, and it's going to ask you what effect do you want means for. Well, because the only thing we're actually interested in is the adjusted means of the group, we're going to say we want effects for the group factor, and it's going to ask us what model do we want to use to estimate these effects, because as we saw in the previous video, the ANCOVA actually uses the model it's created to estimate what the mean would have been. So we call that model HOR, so we're going to pass that to the function. press enter, and we see we get our adjusted means for our group effect. So our no redirect group has been adjusted down slightly from 8.6, and our defense redirect group has been adjusted slightly. So these are the means you would report if you were reporting there was a significant effect of the grouping on the rating after the covariate had been controlled. And then these are the means you'd give, not the means in the descriptor statistics. So I hope that's been helpful in terms of how to do ANCOVA in R, and I'll see you in the next video. Thank you for watching.